This is what happens when too much phosphorus and nitrates get into it. This is cyanobacteria feeds on it and replicates and creates these algae blooms we're all familiar with. This is the network of sensors that's in Lake Erie right now. The monitoring sites, the data collection points, which is super impressive when you think about it, that we have this much technology in the lake. So the airborne team is Nemo, National Environmental Monitoring Operations. And the blood of our thing is a battery management system that uses machine learning to, like when the sensor sends this data back to the cloud, machine learning system checks the battery level, and if it's decreasing, it adjusts the frequency that the sensor is sampling and transmitting data back to the cloud. So it'll gradually, it'll reduce the frequency of transmission until the battery can regain its charge. The idea is to reduce the amount of maintenance that the sensors need. You want to talk about the technology?
So this is a particle I/O dev board, and it uses something called a thread network. So basically, particle I/Os could interconnect. Particle I/O dev boards can interconnect with each other, and every time one interconnects, it further expands its node, and it's compatible with Bluetooth, low frequency mesh networking solutions such as LoRaWAN and regular Wi-Fi and 4G. I'll hand it over back to you.
So this is kind of our prototype plan, 3D printed case, solar panel. We got a hold of some epoxy that Tesla uses to waterproof their electronics. I still don't know how we got a hold of that. Gonna put it in like a pyramid shape and mount it to the side of the dock. The plan is right there basically. They're gonna be 470 feet apart. The thread networking can do up to 500 feet. And the idea is put 2 sensors in each one of those 3 red dots, and then one without the battery management technology and one with the battery management technology to see how it works. This is the dock. I don't know why that's there. The yellow dots are like phase 2 deployment, so like a freestanding water sensor, a water sensor in a stormwater ditch, and then a water sensor in a combined sewer overflow tank to measure the levels and try to figure out a fun thing to do with that. This is the interface that we designed for the data from the sensors. It's not built yet. I hoped it would be, but it's not. It uses geolocation to arrange the data from the sensors in a way that basically the closest ones to you are the ones that show up first on the list. And we also looked at integrating all of the sensors from GLOS data. So if you're someone who uses that sort of stuff, you could easily access it. You want to talk about that a little bit?
So right now, in terms of development status, we have interconnected a Particle I/O's API and also have the battery status plugged into its IDE. And we also connected applets that could track your downtime for the Particle I/O dev board, check the status of the Particle I/O board, and also currently check battery status and when it's online. And we are working with pairing it with a CSS interface that's utilizing geolocation using Google's Firebase API, Google Cloud Maps, and a custom database that's being built. The only thing needing to be done left dev-wise is actually building the database, but we have some of the core API functionality and want to work on building the database and connecting the battery management algorithm to it.
So we have a plan, it's just not done yet. We were going to have a demo to the app on here, but it's not done. So there's a link to the white paper, like the research technology that the battery management technology is based on. The other teammate of ours, Jack, that was actually his master's thesis project at Wayne State, so it's really impressive if you want to check it out. This is our timeline. Jack's thesis project, team forming, semifinals. Didn't get a couple of things done on the rest of it, but not bad. Next steps are basically deploy more sensors, build a bigger interface, and that's it. This is the team. Thanks.